All right, today we're doing section 12.8, last section we're going to cover in geometry. You'll notice we skipped 12.7 to make sure we had time to get in the chapter 12 test. 12.7 is not anything that shows up on any of the standardized tests or anything, so it's not a big deal to skip that one. So we compared surface area and volumes of spheres, so we looked at those equations, and hopefully by now we have our equations set up in our notes pretty well. We've identified congruent or similar solids. So if two solids are similar, they're the same shape but a different size. If they're congruent, they're exactly the same. And use properties of similar solids. So we've looked at this before. Now we're going to look at similar solids. So solids meaning prisms and pyramids and spheres and things like that. And talk about what it means to be similar or congruent solids. Okay. So first one is similar solids. Two solids are similar if they have the same shape but a different size, and the ratio of their corresponding linear measures, so radii, heights, slant heights, all of that kind of stuff, are in proportion. So those ratios are the same. So if I took R1 over R2, H1 over H2, it would have to be the same ratio. So if they're going to be congruent, all of the corresponding parts have to be the same. So corresponding angles are congruent, corresponding edges are congruent, corresponding faces are congruent, and the volumes have to be equal. It's exactly the same size and shape. So determine whether the pair of solids is similar, congruent, or neither. Well, I can tell right off the bat that they're not congruent, because if you look at the heights, they're not the same, the edges aren't the same, etc. So I know they're not congruent. What I need to do is compare those ratios to see if they're the same. So I'm going to go ahead and set those up. If I get the same ratio, then I'll say they're similar. So the ratios between the corresponding parts have to be the same. So base edge over base edge. So 5 square roots of 5 over 2 square roots of 5. The square root of 5's cancel, you get 5 halves. Okay? What about the heights? 5 square root of 7 over 2 over the square root of 7. You can multiply, instead of dividing by the square root of 7, you can multiply by the reciprocal, 1 over the square root of 7, and then your square roots of 7 will cancel. So you do get the same thing, 5 halves. And then we had one of those edges as well. And square root of 3's cancel, you get 5 halves. So all of them have the same ratio. You would say these are similar figures. They're not congruent because they're not the same, but they are similar. Okay? How about this one? Okay? Well, 6 over 6, those look to be the same. 15 and 16 though, okay, they're not congruent because they're not exactly the same, and they're not similar either. 6 over 6 is not the same as 15 over 16, so this is a neither situation here. Okay, 6 over 6 compared to 16 over 15, not the same. So what do you guys think? Give this one a shot. Okay, so for me, they're certainly not congruent, right? 4 and 9, 12 and 27, not the same. But, okay, 4 over 9, that obviously simplifies to 4 over 9. 12 over 27, okay, is there a number that goes into both 12 and 27? 4 goes into 12 3 times, or I'm sorry, true, but 3 goes into 12 4 times, and 3 goes into 27 9 times. Those are the same ratio, so I think we would have to say that those are similar, okay? How about these two shapes? Again, not congruent. The heights are 8 and 10, the edges are 6 square root of 2 and 9 square root of 2, etc. But I don't know if they're similar or not, so we're gonna just compare. So the heights, 8 over 10, 2 goes into 8 4 times, 2 goes into 10 5 times. All right, so I've got that scenario. Okay, what about this lateral edge? 6 square roots of 2 over 9 square roots of 2. Well, the square root of 2's cancel. 6 over 9, 3 goes into 9 twice, 6 twice, 3 goes into 9 3 times. That's not the same ratio, you guys. And 12 over 15, it wouldn't matter if it was one or the other, but the fact that these two aren't the same means we've got a neither situation, okay? So we're just comparing those ratios. All right. A couple of things. If two similar solids have a scale factor of A over B, then the ratio of their scale factors is A squared over B squared. We saw that before in chapter 11. And then the ratio of their volumes is A cubed over B cubed. Okay, so that's something you have to keep in mind. So two similar cones have radii of 9 and 12 inches. What is the ratio of the volumes? So that's your scale factor, 9 over 12. Okay, and I can simplify that. You always want to simplify it. It's going to make your life easier. So this is A over B. we said the ratio of the volumes was A cubed over B cubed. Well, 3 cubed is 27 and 4 cubed is 64, so 27 over 64 is going to be that ratio, okay? Why don't you give one a shot? Okay, it says two similar cones have radii of 5 and 15, so that's going to be the scale factor. I can simplify that. 5 goes into 5 once, 5 goes into 15 3 times. So that's your A over B. Okay, A cubed, 1 cubed is 1. 3 to the third power is 27. So 1 over 27 is going to be the ratio of the volumes here. Okay, softballs shown are similar spheres. Find the radius of the smaller softball if the radius of the larger one's about 1.9. So I know this is 1.9, okay? And I know the volumes, but that doesn't help me with scale factors. So what I have to do is figure out what A over B is. I've got A cubed over B cubed, and I have to go back to A over B. So that's A cubed over B cubed, okay? The pi's cancel. But if this is A cubed, how do I get back to A? I need to take the cubed root, okay? So the cubed root of 4.06 is about 1.6, and the cubed root of 9.15 is about 2.09. So the ratio or the scale factor is 1.6 to 2.09. Well, that's going to have to equal x over 1.9, right? To set up those radii. So now I just have to solve a proportion, which isn't too bad, okay? Cross multiply and divide, you get about 1.45, okay? All right, why don't you guys check this one out? Okay, so the ratio of the volumes is 80 pi over 270 pi. We know the pi's cancel right off the bat. And again, this is A cubed over B cubed. I can simplify this a bit. Let's divide everything by 10, and I get 8 over 27. Again, this is A cubed over B cubed. So then what's A over B? Okay, well the cubed root of 8 is 2, and the cubed root of 27 is 3. So your scale factor is 2/3. Okay, so now I'm going to say 2 over 3, small to large, is equal to height over 6. Okay, so 6 times 2 is 12. 12 divided by 3 is 4. So we should get about 4 inches for that height. Okay, so that's how you're going to tackle a problem like that. All right. Good luck. I'll put the assignment on Google Classroom. Thanks, guys.